Hello friends, welcome you all to the series of MATLAB tutorial. In last session, we have learned about MATLAB operators. Now time to learn numbers in MATLAB. We will begin by talking about the basic information of numeric types in MATLAB. Then we will go bit in deeper about the conversion to various numeric data types, functions to find smallest and largest integers in MATLAB. And as usual, for your better understanding, I'm gonna keep this session mixed with theory part along with a live demonstration of MATLAB scripting examples. What is the numeric types? Numeric classes in MATLAB include signed and unsigned integer and single precision and double precision floating point numbers. By default, MATLAB stores all numeric values as a double precision floating point. You cannot change the default type and precision. You can choose to store any number or array of numbers as integers or as a precision. Integer and single precision arrays offer more memory efficient storage than the double precision. All numeric types support basic array operations such as indexing, reshaping, and mathematical operations. There are few dimensions and the categories which are fall under the numeric type functions, such as numeric variables, conversion between numeric types, query type and value, and last is numeric value limits. Now, here are functions which falls under the numeric data types. And here is a table for MATLAB numeric data types and their corresponding description. Now time to dive in MATLAB for real-time demos. Let's start and let's go to the MATLAB. As usual, to save your time, I already have created script around these data types. So here is the program. Let me open this and you can see the script which I already have developed to save your time and to present the various numeric data types. Very simple example we are gonna start today. I have created one variable as an array and taken few values. Some array with the values negative and some values as a positive. These are the floating point values. So minus 3.4 is the first value, second value is 5.6 and the third is a minus 6.7. So this is an input array. Now, as we have seen earlier on the table, single, double, integer. These are the data types. If we pass the argument or the input that is actual, the variable with this syntax, then that converts that entire number in a single precision number. And that is what we're gonna see here. So for your understanding, I have taken simple, double, integer 8, integer 16, unsigned integer 16, unsigned integer 64 as well. So let's run this program and see the results. Very simple. We will see this example and we'll see how the results looks. Either you can press F5, either you can hit this button, or you can enter the Control plus Enter button. Here I have run the program. Now you see here, this was my input and here is my input array. After running this program, A looks like the same because these are the single precision numbers. So same array is reflected here, right, with the same values. For the double precision number, same story because this is falling under that limits. So minus 3.4, 5.6, minus 6.7. is also reflecting under the um, result of B as well. And if I go for the result of C, it's an integer, 8-bit signed integer. So I want the sign for my values passed through this array, and that should be in the integer form. So what is happening? This 3.4 is rounded off. 5.6 is rounded and converted into integer, and 6.7 is also rounded off and converted to the integer. So 3.4 is a 3. That's what I'm getting, 3. 5.6 is rounded off to the 6, and 6.7 is rounded off to the 7. And as this is a signed integer array, I'm getting the sign as well. So minus 3 plus 6 and minus 7 is the result for C. Same for the integer 16, that is a 16-bit signed integer array. Here again I am getting the results in the form of sign. So minus 3, and again this 5.6 is rounded off to 6, and 6.7 is rounded up to 7. But the symbols are there. So minus 3, 6 and minus 7 is the result for 16-bit signed integer array if we convert that data types uh, from the origin to the 16-bit signed integer array. If I go for 16-bit unsigned integer array, that means I don't want the sign. This data type says I want only the positive numbers. So that's the reason this minus 3.4 is not falling under the range of these data types. So that's what that value is replaced with the 0. As this 6 is rounded off and 5.6 is rounded off to 6, and this is in the range of this data type, so that value we got here, that the 6. And again the negative number is not falling under unsigned integer arrays, so that's the reason this value is replaced with 0, and here we are getting the result 0, 6, 0, and that is expected result after this data type conversion. And again the last data type, that is unsigned 64, that is 64-bit unsigned integer array. The same results we are expecting here, because again this is an unsigned integer. We don't expect the sign to the integer array, and we get the rounded off results as well. So here I will get 0, here I will get 6, and here I will get again 0, and that is what I'm getting result in F, which is stored in the F. That's all, very simple, falls under this numeric data types. Are the two functions commonly used to convert between different numeric types? Now let's dive in MATLAB for real-time demo and see the example how cast and typecast numeric data type works. Now we have seen the two functions which are commonly used to convert between the different numeric types, and that are cast and typecast. Now let's dive into the MATLAB with some examples of cast and typecasting. So here I have created the example. The cast function basically used to convert the variable into the different data type. Here I'm starting with the example which I want to convert integer 8 value to the unsigned integer. Already created one vector is a variable with the name input. It's a vector with a value of minus 3.4, 5.6 and minus 6.7. But this declaration defines the vector of 8-bit integers. So when we run this section, the input variable will store the value of minus 3, 6 and minus 7, because this 3.4 and 6.7 will get rounded off. But here is the catch. With the help of cast function, this vector, 8-bit integer vector, I'm converting to the unsigned 8-bit integer. So the value minus 3.4 and minus 6.7, these are the values which are outside the range of unsigned integer 8 data type. So what will happen? These values will get truncated to 0. So this minus 3.4 will get replaced with 0. Again, this will get replaced with 0. And this value will rounded up to 6. You will get the answer 0, 6, 0. Let's run this section. Control Enter. Now in the input you see -3, 6, -7. As I said, as we are converting this with the data type of integer 8. So this value is also rounded up with the sign. That's what the integer 8 is a data type. So -3, 6 and -7. But when we use this unsigned integer, you see as these values -3.4 and -6.7 are outside the range of this data type, that values are truncated to 0, and that's what the result we got, 0, 6, 0. This is how the cast function works. The next one is a typecasting. Here again I have created some example. So typecasting allows you to convert data from one type to another without altering the underlying data. That is very important. You can convert the data from one type to another, but which allows you not to alter the underlying data. So whether you are squeezing bits together or rearranging them. So MATLAB's typecast as well as the cast function comes very handy. Suppose you have an integer. So here is the integer row vector, and that is represented by the values of 77, 60, 43 and 26. I have created the integer row vector. With the help of this typecast, what I'm going to do, I am converting the four 8-bit integers which use the 4 bytes of 32-bit of storage to a single precision number that also uses the 4 bytes. So data type I want to convert that is a single precision. So that's what I use the single typecast function and this value x. And so actually what happens when you run this entire typecast function, use the typecast function, run this code, you will get the bit pattern remains the same. But now you have got the single data type. So let's run this and you will get the single data type. It's very simple. So control and enter. So here is the x, that is 77, 60, 43 and 26. But if you look at the y, that is the -3.5 and the e raised of -23, because we are typecasting that to the single. And if you look at the formats, you can get the hexadecimal values for this 77, 60, 43 and 26. So you can get the result here 1A, 2B, 3C and 4D accordingly. So 4D is for representing this, then 3C is representing this, 43 and 26. So this is for the formatting of the hex, just to represent this x. But the importance is here and here, because here you are declaring the variable with the integer 8 row vector, and that value is integer 8, and you are converting that to the single precision. Ultimately, at the end, the bit patterns are remain the same, but now you have got a single data type. This is how you can use the cast and typecast function. These are the simple examples. Here are the list of MATLAB functions which are query type and value. And this is a time to dive in MATLAB for a real-time demo. In theory part, we have seen the different functions which falls under the query type and value that are all finite, any nan, is integer, and blah blah blah. Now time to dive into the MATLAB practical examples. I have taken the two simple examples. Very simple. I'm starting with the one function called all finite. This function determines if all array elements are finite, and accordingly it returns the answer. It returns the logical one, that is a true, if all elements of a variable are finite, and it returns the 0, that is called false, if any element is not a finite. So it checks for all elements. If single element is not a finite, then the answer or the return value is a false, that is a 0. A is the variable I created. and I am dividing 1 by this array, and the value is -2, -1, e raised to -23, a very small value, and then the 0.1. Ideally, the answers are expected here, that -0.5, -1, and blah blah. But here is the real check. We want to check either the value computed under A or stored under variable A are all finite. Yes, the values are all finite. We don't see any infinite value. Then it returns the 1. And for the another example, if I divide 0 by these values, the catch is here. 0 division by 0 is not a number. So it will return not a number. But this array is basically the B array is a 0, 0, not a number, and some 0. 0 is a finite value, but not a number is not a finite value. So answer 2, you should get a logical 0. That means logical false. That means 0. So if I run this section, control enter, you will get the answers. So A is the array. And if I use the all finite function on that array, then I'm getting the answer 1. The reason, all elements are actually finite elements. But in the B, if I look, elements in the B, third element is not a number. And that's the reason if I check for the answer to variable, I'm getting the false here. This is how you can use the all finite function. The second function is very simple, that is integer. And this is integer function determine whether input is integer array or not. Integer type in a MATLAB includes integer 8, integer 16, integer 32, integer 64, unsigned integer 8, unsigned integer 16, unsigned integer 32, and unsigned integer 64. I use the word integer, but it's actually the keyword is int. So int 8, int 16, int 32, int 64, u int 8, u int 16, u int 32, and u int 64 are the integer types used in the MATLAB. And if taking the simple example, answer 3 is a variable, and using the 5 and starting checking with this is this 5 is integer. Here I am getting the answer 0. Why? Because the MATLAB store a real number as a double type by default. So here the double type is type double is a default, and we are checking is this integer. That's what we are getting answer 3, and we should get answer 3 with the return value of 0. But if we check, if we convert that in the integer 8, and then we check with the is integer, then definitely we'll get the answer 1. Very simple. Let's run this section and check. So I'm using the control enter, and here I'm getting answer 3 as expected, it is a 0, right? And answer 4 as expected, it is returning the 1 because 8 is a integer array, and this is not the integer array because double is by default considered data type in the MATLAB. That's all under this query type and the value. Final topic today is a numeric value limit functions, and here is the list of functions and corresponding description. Let's quickly jump to MATLAB and see how these functions works with few examples. Let's explore numeric value limits in MATLAB. Whether you are dealing with the symbolic expressions or plotting data, MATLAB provides tools to handle limits effectively. Here is some examples I already have created. We have seen the different functions like EPS, int max, int minimum, and blah blah blah. So out of that, I just picked up the few functions. Let's start with the EPS. When you call EPS, without any argument, just let's say EPS, or if you type EPS and in open curly bracket 1.0 or 1.0, then it returns a value of approximately 2.2 e raised to minus 16. And this number represents the distance from the 1.0, that is the 1, to the next larger double precision number. In other words, it's the smallest increment you can add to 1.0 and still get distinguishably different number in the world of doubles. That's the simple explanation about this EPS. And if you come put log 2 in bracket EPS, you will find that the EPS is equal to 2 raised to minus 52. That's some serious microscopic precision. That's the funny part, but yes, this is how the EPS works. So I started with the EPS. I'm defining the A is equal to EPS. I'm not passing any value here. That means it should return the very smallest number, and that number should be approximately 2.2 e raised to minus 16. When we pass the value 10, that means what we are expecting, we are in terms, this function will return the distance from 10 to the next larger double precision number. And when I write C is equal to EPS and pass the data type that is a single, that means this EPS in bracket single is equivalent to the EPS in a bracket single with the argument passed in 1. So this is how it is equivalent to this value. So let's see how this works. I'm just entering control and enter button, and here is the smallest value which are presenting the different meaning. A is equal to EPS, that means as I said like 2.2 e raised to minus 16. So here I'm getting that value. And this number represents the distance from the 1.0, that is 1.0 means 1.0, the next larger double precision number, and that value is 2.2. When I say EPS 10, passing the value 10, I'm getting this value B is equal to 1.77 e raised to minus 15. And when I say EPS single, that means this is equivalent to EPS single and passing the value 1, and you get the value here, that is 1.19 into e raised to minus 7. So this is how the EPS, that's floating point relative accuracy, it works on this number. Now the next topic and the next function, that is int max and int minimum. Very simple. When I say int max, this is the largest value of a specific integer type. You can define the specific integer type, integer 8, integer 16, integer 32, integer 64. That way you can define. But let's just check with by just typing the integer max. I'm storing that value into D. It will return the largest value of a 32-bit signed integer type. When you don't define any data types in the parentheses, then automatically it picks up this is a 32-bit signed integer type. And that is the reason it will return this 21474836647 positive side value. That is the maximum value. If we go for the next usage of this int max and you define the data types inside that integer 8, then you will get the maximum value of 127. And of course, in the integer 8, if you look for the range, this 127 is the maximum value. Similarly, for the integer 16, you will get a 32,767 is the maximum value. In the same section, I have created for the int min function. And this int min function returns the smallest value of a specific integer type. That's what it is written int min. If you define the specific data type integer 8, the minimum value is a minus 128. If you define the integer 16, the minimum value is minus 768. So it starts from minus, the range for the integer 16 is minus 32,768 to positive 32,767. And out of that, the minimum value is a minus 32,768. So let's run this section and let's check the values are rightly calculated. Okay, so I run this section. So for the D, let's check. Yes, I'm getting the positive value, and that is the 32-bit signed integer type, and it's the largest value. Yes. For the E, when I say integer max, and the data type is integer 8, then the range starts from minus 128 to 127, and the 127 is the maximum value for the range of this data type, and that is what we are getting 127 here. Same for the f, because f is integer 16, so we are getting positive value 32,767. In the minimum side, when I don't define any data type, I don't pass any data type argument, then I get by default it returns the largest value of it, smallest value of the 32-bit signed integer type, and that smallest value is a negative value I'm getting here. When I say int minimum of integer 8, if I pass the integer 8 for this function int min, then I will get the minus 128, and that is what the value I get stored in the h. Here is the minus 128, and same for I, because this is integer 16, so I am getting minus 32,768 is the minimum value in the data type integer 16, and here I got that value. This is how the numeric value limits functions works. Very simple example, and now you can start exploring other functions as well. After watching this video, I'm sure that you understood various numeric classes that include signed, unsigned integers, signed precision, and double precision floating point numbers. If you really like this session, then please give the video a thumbs up. Watch more videos like this one, please consider subscribing. Once you hit subscribe button, you're gonna get the notification anytime. And lastly, if you have any queries on this topic, you're gonna answer me, leave me a comment below. I read them all. That's all I have for you today. Hope you enjoyed and hope to see you next time soon. Bye bye.